So when we talk about molecules and we talk about them and draw them, we tend to draw them flat on flat pieces of paper. But in reality, molecules are three-dimensional. And there's a theory, the VSEPR theory, which is the valence shell electron pair repulsion theory, that explains the three-dimensional shape of molecules. This all begins with a Lewis structure. So here's our first Lewis structure. A stands for any atom, and these are the atoms that are bonded to A. Electron groups don't like each other, so they will try and spread out as much as possible. So if we have two groups, we will find that they are 180 degrees apart. That gives us a linear structure, like that. We will write this as A with two bonded atoms, and that's linear. An example of this is beryllium fluoride. Okay, now what if we have a molecule and it's got three bonded atoms? Well, those groups will want to be as far apart from each other as they can, so we get 120 degrees. Here's a sample of a trigonal planar. It's trigonal because it's got three groups, and all three groups, if I hold it right, are in a plane. Like all the atoms are in a plane. So we call this trigonal planar. And we would write the groups as we've got a central atom and it's got three groups bonded to it. So it would be an AB3. An example of this is boron trifluoride. All right, so what happens if we have an atom and it's lost, or doesn't have one of its atoms? So this has a lone pair here. This is a lone pair. And for a Lewis structure, we would write it like this. We have a central atom. It's bonded to two other atoms, and it has a lone pair. The shape here, we don't see the lone pair, so the shape is bent. We write this as being bent. Our notation is going to be that we have a central atom, there are two bonded atoms, and we have one non-bonding lone pair. And that's a bent shape. What if we have an atom and it has four groups attached to it? The four groups will want to get as far apart from each other as they can, and we get this shape, which is a tetrahedron. Each of these atoms are 109.5 degrees apart from each other. Okay? This was a tetrahedral. And our symbolism here would be an atom in the middle with four bonded atoms. What if we have this Lewis structure? here we've got 3 bonded atoms and a lone pair. So let me retake my thing. I'm going to remove one of my atoms and see what shape we have left. Remember, we don't see the lone pair. So what we have here is a trigonal pyramidal shape. It's trigonal because we've 3 groups, and it's a pyramid. You can see that the black one is not completely on the ground. Okay? So that's different from the one that was trigonal planar. Let's write that down. And we would write this as a central atom. We've got 3 atoms bonded to it, and we have 1 non-bonding lone pair. Okay. So the very last one, so we have an atom, and it's got 2 lone pairs and 2 bonded atoms. So it would look like this. Remember, we don't see the lone pairs, but they're there. They take up space, and they push these 2 atoms close together. So this gives us a bent shape. And we would, our notation for this would be a central atom, 2 bonded atoms, and 2 non-bonded atoms. Okay, so let's look at all this on our chart. You can get to it. It's under here somewhere. There we go. If I have 2 electron groups, that's this one, our electron group geometry is linear. We have no lone pairs on this atom. Our VSEPR form is we have a central atom with 2 bonded atoms, and a molecular shape is linear. Okay, we've got to put this guy back together again. If we have 3 electron groups, an electron group is a bonded atom, or it could be a lone pair. So here we have 3 electron groups. Our shape, our electron group geometry is going to be trigonal planar. And then we divide it into 2 parts. If we have no lone pairs, then our VSEPR form is a central atom and 3 bonded atoms. And our molecular shape is trigonal planar. A there, sorry. Okay, the second part of this, what if we have 1 lone pair? Let's take off one of our atoms. So now we have a molecule that has 2 bonded atoms and 1 lone pair. So we have 1 lone pair. We end up with a central atom, 2 bonded atoms, and a non-bonding lone pair. Well, our shape is bent. The electron group geometry stays the same because we still have 3 electron groups. We've got 2 bonded atoms and a lone pair. Okay, so let's look at number 4. if we have 4 electron groups, we'll end up with a tetrahedral. And we have the choice here of having 0 or no lone pairs, 1 or 2. Okay, if we have no lone pairs, we'll write this as with 4 bonded atoms, and we have a tetrahedron. If we have 1 lone pair, then we get this shape. Our electron group geometry stays the same. We still have 4 groups, and it's still tetrahedral, but we have a central atom with 3 atoms bonded to it and a non-bonding lone pair, and this is trigonal pyramidal. If we take off another atom, we end up with a molecule that has 2 lone pairs, so it's A, B, 2 bonded atoms with 2 non-bonding pairs, and it's bent. So we can use the VSEPR theory then to predict the shape of molecules. So let's start with this one. We're first going to begin by doing a Lewis structure. And so we need to know how many electrons we have. This is in the column, so it has 6 electrons, and bromine has 7 electrons, and there are 2 of them. So that gives me 20 electrons. So each one of these counts as 2. It's 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have our Lewis structure. Now we can look at our Lewis structure and see that we have a central atom. We've got 2 bonded atoms, and our central atom has 2 lone pairs that are non-bonding. Note, we don't pay any attention to the lone pairs that are around the bromines, just the 2 lone pairs that are on the central atom. And you can see this matches up with a bent shape. So actually, I've drawn it badly, and we should be drawing it bent at about, this will be about 109 degrees. Okay, so let's look at carbon tetrachloride. We've got 4 valence electrons from the carbon, and I have 4 chlorines. Each one's going to have 7. It's 32 electrons, if I did the math right. And carbon is going to go in the middle because the halogens only like to make 1 bond. Okay, so 2, 4, 6, 8 electrons are used in our bonds. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, so I have enough electrons. I don't need any double bonds or anything fancy. We want to look at the structure. We want to look at the central atom. We see that it's bonded to four things. So we've got carbon, or we've got, as far as structure, we've got a central atom, and it's bonded to 4. If we look up here at our chart, our table, we see that a central atom bonded to 4 will have a tetrahedral shape. So as long as you can draw the Lewis structure, and you have a table like this, you can tell what the molecular shape is.